Good morning. No camera today. I guess it could be afternoon where you are, but whatever. Um, so we got three examples to do here on pendulums and harmonic motion, pendulum springs and harmonic motion. So the first one, a zero point 0.1 kilogram mass on a string is oscillating harmonically with a frequency of 5 hertz, an amplitude of 0.05 meters. What is the max acceleration? Right. So I've got a frequency of 5, right? So frequency is 5, and I kind of want omega. Omega is going to be more useful in a lot of these equations, right, when we think about it. So omega is just 2 pi times the frequency, which is 10 pi, right? And because that's 10 pi, we can just go to A max, right, which we know is x max, right, omega squared, which is just going to be 0.05 times 10 pi squared, which is 5 pi squared. Okay, it's pretty straightforward. All right, that's a pretty easy one. Using the relationship, get into omega, and then use the A max, V max, or X max equations for those kind of maximum situations. All right, second one here. I got to draw you a graph here. I realized I didn't do that ahead of time. So we got a graph. It's V versus T. And our oscillations are that. And then this is 10 meters per second at the maximum. And this is 0.25, this is 0.5, etc. 0.75, I guess, seconds. I should put the S there, it's going to look like it. All right, so first thing, looking at this graph, one period is when the velocity is going to go from 0, positive, 0, negative, 0. So that's a complete cycle. So I know the period is 0.5. I also know that V max is 10. Okay? So my period is 0.5, then my frequency is 1 over 0.5, or 2, which means my angular frequency is 4 pi. I know my Vmax is 10. Okay? So I know that Vmax is omega, right, times Xmax. So Xmax is going to be Vmax over omega, which is 10 over 4 pi, or 2.5 over pi. Okay. All right, those are pretty quick. Third one's a little bit more. Pendulum made up a thin rod of mass m in length 1 meter and a small sphere of mass m. The pendulum has a period of t when the pendulum sphere is halfway down the rod. So basically what we're saying is in the first case, right, you've got this little fixed, this little rod, and we're going to put the mass right in the middle there. Okay? And then the second case, now the sphere is attached to the end of the rod, so now we're doing, right, same thing, now the sphere is down there. Okay? So this is A, this is B. Okay, the period A is just t. And I want to know what the period B is. Okay? So, these are not simple pendulums, right? The mass is not distributed quite so, or the mass is not all at the end. Even in the second case, B, it's not all at the end. So what do I need to do? Well, we know that the period of a pendulum is 2 pi square root of I over R mg. And I want to be very clear, this R right here, this is the location, the radius of the center of mass. So let's think about it. What's RA? This is easy. The center of mass of the rod is in the center, and hey, the sphere is in the center. So RA is just going to be 0.5. For RB, it's actually also simple, right? It's 1 and 0.5. And since they have the same mass, it's 0.75. Okay, then we have to also do the I. IA is going to be I of the sphere, or I of the bar, right? Which is, we know around one end is 1/3 ml squared plus mr squared of the sphere. So that's m times 1/2 L squared. And L is just 1, so this is IA is equal to 1/3 m plus 1/4 m, or 7/12 m. IB is also still 1/3 ml squared, but now it is plus m and just L squared. So that would be 1/3 ml squared plus, or 1/3 ml, or 1/3 m, right? Because L is 1, plus m, or 4/3 m. So let's put that in there. So TA, or just T, I guess we could say it is. T is equal to 2 pi square root of 7/12, I guess m times 7/12 over 0.5 mg. Ooh, and I gotta be careful here. This m, this is not m. That m is 2m, right? So 0.5 times 2m times g. The m's cancel, the 0.5 and the 2 cancel, so I should get this is equal to 2 pi square root of 7 over 12 g when I simplify. Same thing over here. dB equals square root of m times 4 over 3, all divided by 0.3, right? That's at 0.75 for the r, times 2m g. Again, we get a little bit of cancellation, but I should get that TB is equal to 2 pi square root of 8. Is that right? 8/9? Yeah, 8/9. 8 over 9g. Okay. So now I just want TB in terms of t. Well, so basically TB equals 2 pi square root of 8 over 9g divided by 2 pi square root of 7 over 12g. When we do all that out, you get the square root of 96 over 63 times t. All right, that's it.